Alrighty guys, welcome back to the shop. Today we're going to be installing a Bluetooth digital readout on my Little Machine Shop mini mill. When the guys at littlemachineshop.com sent me this mill, they sent it with this DRO system. So this video is in essence sponsored by littlemachineshop.com. The kit comes with all the necessary components to attach the DRO to the 3990 mini mill and other mills in the same class. I'll put a list of compatibility here. You'll receive a detailed set of instructions that will guide you through the installation process. That being said, one of the reasons I'm making this video is to provide y'all with a more detailed installation guide, since I did find the instructions to be a bit confusing in a few spots. The first step is to remove the back chip guard from your machine to get it out of the way. You'll be installing one of the DRO readers in this area on the X-axis. To get to this spot, you're also going to need to remove the column from the mill. Be careful here, since this column and head can be a little awkward to handle. I put a board on the table to protect it, just in case I slipped. I then detached the mill base from my workbench and turned it around so that I can get full access to the back of the machine. We're going to be drilling and tapping some holes for the X-axis magnetic scale. Depending on the model of your mill, there will be different hole locations to drill. In my case, the distance from the ends of the table was 45 millimeters. Take great care in getting the hole spacing accurate, since there really won't be much wiggle room when mounting the magnetic scale. You'll be drilling two M3 holes to a depth of 8 millimeters. The bit size will be a number 39 and the tap is an M3 and 1/2 millimeter thread pitch. As you can see here, I used a piece of masking tape to mark my drill depth. This worked very well. Once these holes are drilled and tapped, you can go about attaching the magnetic scale to the X-axis with two provided M3 10 millimeter panhead screws. Depending on your mill, you may also need to drill some M4 holes into your saddle in order to attach the reader. The Little Machine Shop 3990 mill already has these holes drilled and tapped. At this point, the rectangular block standoff and L-bracket reader mount can be installed on the saddle. The reader head sits in a thin caddy that has two chip plows on both ends. This is to protect the reader from debris. From a spacing perspective, you want the reader head to be a hair away from the magnetic scale, but close enough for the rubber plows to touch the scale and protect the reader. As you can see here, we have a nice smooth X-axis operation that extends to the full travel capacity of the mill table. The next reader we'll install will be the Y-axis travel. This one is a little harder to get to for sure. On the Little Machine Shop high torque mill, there are already two holes in the saddle that we'll use to attach the scale bracket, but we will need to drill two holes in the base to mount the reader head assembly. These M4 holes will need to be drilled and tapped 158 millimeters from the front of the mill base and spaced by 12 millimeters from each other. We used the two existing M4 saddle holes I mentioned earlier to attach the scale bracket. After that, we can attach the Y-axis magnetic scale to the bracket with some M3 panhead screws. To attach the reader mount to the base of the mill, the kit comes with some studs that will be used as standoffs. You'll screw the studs into the base and use nuts and washers to space out the reader. As constructive criticism, I think the reader mounting method could be improved with a custom block spacer like the other two axes in the kit. It was a little finicky to get the spacing right with the nuts and washers, but with some patience, it wasn't a huge deal. Now, it could have been my mistake, but I did run into an issue with the Y-axis. The reader head was positioned too high on the magnetic scale by around 2 to 4 millimeters. While it may have still worked, I wanted to fix it while I had the mill apart. To do this, I simply filed the slot larger to drop the head down some. Since my slot was now larger, I wanted to have washers on the front of the bracket as well. I didn't have any 4 millimeter washers on hand, so I made a custom tandem washer out of a spare larger washer. This did take a little extra time, but it would have taken me even more time to drive to Ace Hardware to get some 4 millimeter washers. I then attached the reader head to the bracket and tested the Y-axis travel of the mill. Like I mentioned earlier, this axis was the most difficult one for me to install, but all in all it really wasn't that bad. I'd probably suggest to littlemachineshop.com that they should add a couple extra 4 millimeter washers to the kit. With both the X and Y axis installed, we can remount the column head onto the mill and install the Z axis travel. As y'all probably noticed here, I carefully reinstalled the shims I use for tramming the head of the mill. However, I think it would be worth my time to retram this mill, considering we had it all apart and things could have shifted. One thing that's worth mentioning with this DRO kit, and probably any DRO kit you install, is that the Y-axis travel will be impeded by the reader head on the x-axis. In the case of this kit, it looks like the reduction of travel is around 1 3/8 of an inch. I was impressed by the tight tolerance between the z-axis scale bracket and the column mount, since I was a little concerned about this when installing it. Now we're on to the z-axis installation. This is one part of the install that I deviated from the instructions, which I'll get to in a minute. The basic install procedure is the same for the z-axis as it was for the x-axis. You drill and tap some M3 holes into your column for the magnetic scale, and drill and tap some M4 holes into your mill head to attach the reader bracket and reader head. With the magnetic scale installation, a good tip is to drill and tap the top hole first, attach the scale to that top hole, and then use the scale itself as a guide to scribe the bottom hole. This same method could have been used with the x-axis with great success. The mounting system for the reader head bracket is the same on the z-axis as it was on the x-axis. I started off by installing the z-axis magnetic scale based on the dimensions given on page 5 of the instructions, with a 110 mm distance from the top of the column. However, after having it installed, I didn't like how this limited the upward travel of the head. I took some measurements and determined that this 110 mm dimension could be changed to 78 mm, which would allow for a full z-axis travel in the upward direction. Moving the scale up was painless and only required drilling and tapping 2 more M3 holes in the column. This adjustment does limit the downward direction of the z-axis slightly, putting the spindle about 1 inch off the table surface. I felt like I'd rather have the upward space for working on hidden tang handles, and most of the milling I do involves a vise anyway. So that sums up the mechanical installation of the DRO, and while it's daunting at first, in practice the job wasn't too bad. Overall, it took me a few hours to get it done, and I feel like if I had a detailed video guide like this one, I could have gotten it done a lot faster. The next section of the install will be focused on the electronics. Don't let this part scare you off. I know wiring can be confusing at times, but in this case the setup is super easy. The instructions from Little Machine Shop are simple to follow, and each of the 3 axes are wired the same way. Each axis has a green plug that will be wired up to the end of your reader wires and then connected to the Bluetooth transceiver. I'll slow down and zoom in so that you can get a good view of this, but the order from left to right is red, white, yellow, brown, and gray. After all 3 plugs are wired up, all that's left to do is plug them into the appropriate receptacles, then position and tighten the cable clamps at the bottom of the transceiver to hold everything securely. Before closing up the box and remounting my mill, I wanted to make sure everything was working. You're going to need an Android device to connect to your DRO system. I'm using an old Nexus 7 that I purchased back in 2014. Go to the App Store and make sure you download Touch DRO. Next, you'll have to go into the settings of your device, find the Bluetooth section, and pair it with the transceiver by selecting it on the list. For me, it showed up as HC-06. At this point, the Touch DRO application should be able to connect to your transceiver. Open Touch DRO, click on the Connect button at the top right, and select your transceiver. I moved the axes around a bit just to make sure I was getting movement on the Touch DRO application. After that, we can close up the enclosure and get the mill situated on the workbench. The transceiver box has magnets on it so that it can snap to the back of your column, which I thought was a nice touch. I ordered this switch for the power supply from Amazon so that the transceiver isn't on all the time. This add-on seemed like a no-brainer to me, and if y'all are interested in the one that I used, I'll put an affiliate link in the description below. Before we go on to the calibration process, I wanted to show how I mounted my Nexus 7 to the wall. I've been carrying this mount around in my scrap pile since 2013, and I'm happy to finally have a use for it. The nice thing about this system being Bluetooth is that there aren't any wires hanging all over the place, and you can put this tablet anywhere you really want. So now that we are mounted and everything is working, I'm going to get behind the camera and take y'all through the calibration process of Touch DRO. This is how you calibrate your axes. This is what you'll see when you log on to the application. You'll have 3 decimal places. Step number 1 is to bring the decimal places up to 4 by going into the settings, going to readout display format, and selecting the second option, which has 4 decimal places. You'll then go on down to the axis that you want to calibrate, which in my case will be the y-axis. Hit axis CPI and enter in 10,000. Hit OK, go back to the main page, hit 0, And then we will be moving our axis a known distance. In my case, I'll be moving the axis 50 thousandths of an inch. We will now use this number to find the appropriate CPI to calibrate our axes. In this case, my number is 254. You'll take 254 and then divide it by the known distance you traveled. This gives me a CPI of 5080. Go back into the settings, go to the axis that you're looking at, and type in the number you found. Hit OK. Zero your axes. And now you should be calibrated. Let's test it. I'm going to move 50 thousandths of an inch back in the other direction. And now you can repeat these steps for all three axes, and you'll have a calibrated milling machine. I want to throw out another big thank you to Little Machine Shop for providing this equipment for us to install and test out. I hope this video is handy to anyone looking to install a DRO system on their mini mill, and if y'all have any thoughts or questions, make sure to drop them in the comment section below. Also, I'll be putting links to this mill and the DRO system in the description. As a shameless plug, I wanted to mention that I've started another side project channel focused on non-knife making related content called Redbeard Engineered. So if y'all are looking for something different to watch, head on over there. Until the next time, I'll catch y'all on the flip side.